Question number 3, a 5-part true-false question. That's all pre-calc stuff. Let's check this out. So part A says natural log of 3 minus natural log of 11. Is that equal to natural log of 3 over natural log of 11? This is incorrect. This is false. This is not how you apply the rules for logs and the difference of two logs. This should equal, let's make this correct, the log of 3 over 11. And log of 3 over log 11 is not the same thing as log of 3 over 11. So the answer is that the answer to the question that was given there is false, but this is equal to this. That's true. Part B, you're asked about the domain of f of x is equal to the 9th root of x minus 4. Is the domain of this all real numbers? And the answer to this is yes. So if this was a square root or a 4th root or a 6th root or any even root, we would want this to be, let me just write this here. If this was like the 6th root of x minus 4, we would need x minus 4 to be greater than or equal to 0, x to be at least 4 here with the domain, close bracket 4 to infinity here. But if you have an odd root here, odd roots don't care whether you're taking, positive or negative. If you're taking the odd root of a positive or negative number. So as an example of this, so if you have the cube root of -8, the cube root of -8 is -2 because -2 cubed gives you -8. So that's what's going on in B. In C, you're asked about the lines 9x plus y is equal to 1 and x minus 9y is equal to -4. The assertion here, the claim is that these lines are perpendicular to each other. How do we know lines are perpendicular to each other? If their slopes multiply together to give you -1. So let's find the slopes. This first equation can be rewritten as y is equal to -9x plus 1. So the m here is -9. The second equation can be rewritten as -9y is equal to -x minus 4. Divide by -9. Y is equal to 1/9 x plus 4 over 9. M2 is 1/9. And yes, we see the product of M1 and M2 here. -9 times 1/9 does in fact give us -1. Yes, these lines are perpendicular to each other. Okay, question, so this is true. Part D here, equations 2 natural log of x is equal to 0 and natural log of x squared is equal to 0. These two equations have the same solutions. And so the temptation might be that to say that, we can move this 2 upstairs. We can move this 2 upstairs like that. That's how logarithm properties work. But we have to be careful about squares and square roots. Let's just explicitly think about, when is this equation true? When is 2 log of x is equal to 0? 2 log of x equal to 0 is when log of x is equal to 0. That's when x is equal to 1. And over here, log of x squared is equal to 0. We want x squared to equal 1, which has 2 solutions. X is equal to 1, and x is equal to -1. So whenever we see square roots in the equation, squares and square roots, we do have to be a little bit careful here for what's going on. So don't try to use that rule a little bit too much here. These do have different solutions here. So this is false. And then part E, cosine of 5 pi over 6 is equal to negative square root 3 over 2. That is true. I don't know how much there is to say about that. This is 5 pi over 6. You're in quadrant 2. Cosine is negative in quadrant 2, and this is the correct value. It just is very useful to know these values of sines and cosines and things like that.